Hello, grade 8 and 9. Today we're going to look at fan angles. Fan angles revolve around parallel lines. And in geometry, we use arrows to show that two lines are parallel. Fan angles are divided into three. The first theorem that we're going to talk about, which deals with fan angles, is corresponding angles are equal. And when you think of corresponding angles, I want you to think of the letter F. In this diagram, AB and CD are parallel lines, and this is how we write it down. The position of the angles, which are said to be corresponding, are here and there. Those two angles are equal. Let's say this angle is A, and then the second angle is B. According to this theorem, A equals to B. In other words, corresponding angles are equal. And the shorthand form for this theorem is with a dot for corresponding angles, and then you put a semicolon, and you name the parallel lines that have been used in the diagram. AB parallel to CD. These two angles are also considered to be corresponding angles. And so are these angles. Basically, watch out for the letter F in different orientations. Here's another scenario where we have corresponding angles. Here we have several corresponding angles as long as these two lines are parallel, starting with this angle and that angle. Those are corresponding angles. That angle and this one are also corresponding angles. These are also corresponding angles. And finally, these two are also corresponding angles. So corresponding angles can come to you in different orientations. Now let's look at two examples. In the first example that we're going to discuss, we have two parallel lines AB and CD, and our aim is to determine the value of x. Now, if I'm going to highlight the letter F in this diagram, this is what you would see. And according to the theorem we've just discussed, x and 100 are corresponding angles, and therefore they are equal, meaning our solution will look something like this. X equals to 100 degrees. And the reason why we're saying that is corresponding angles AB parallel CD. That's it. And let's look at a more interesting example. Example number 2. In this example, we are also asked to determine the value of x. And once again, we're given a pair of parallel lines, PQ and RS. To determine the value of x, we are going to first locate the letter F. So in this case, it would mean that 4x minus 50 and x plus 100 are corresponding angles. According to the theorem, we can equate those two angles to each other. That is, 4x minus 50 degrees equals to x plus 100 degrees. This is our statement. Our reason, corresponding angles, PQ parallel RS. This time around, our parallel lines have been named PQ and RS. Right, so we have equated those two angles just because they are corresponding according to the theorem. All we have to do is to solve for x. We can start off by grouping the x's on one side of the equation, preferably the left-hand side. So all it means is that this x is to move over, right? And it will become negative when that happens, as well as this negative 50 also needs to go over the equal sign. And when that happens, it will change to positive 50. The next step will therefore look like this. We have grouped or collected like terms. Variables on the left-hand side, constants on the right-hand side. 4x minus x is equivalent to 4 minus 1. Our next step towards isolating x entails dividing by 3. Therefore, the value of x is 50 degrees. That's it. And this is how we have used corresponding angles are equal to determine the value of x in these particular instances. So watch out for the letter F, and usually the presence of parallel lines indicate that there is a chance that we have corresponding angles. The next theorem we're going to discuss says co-interior angles are supplementary. Supplementary means they add up to 180 degrees. Co-interior angles is the letter U in the word fun. In this shape, co-interior angles refer to this angle and that angle. If we add those two angles, the answer would be 180 degrees. If we name this angle A and this one B, all we are saying is that A plus B equals to 180 degrees. And this would be our statement. Co-int with a dot for co-interior angles, semicolon, AB parallel CD. That's it, your statement and your reason. To illustrate this theorem, we're going to use the following examples. In both of these examples, we want to determine the value of x. In example 1, we're given x and 110 degrees, and you can tell from the theorem that we just discussed that these are co-interior angles. And according to the theorem, co-interior angles add up to 180 degrees. So in this case, all we have to do is to say angle x plus 110 degrees is equal to 180 degrees. That's our statement, and we're going to support our statement with a reason. The reason is basically what we said here. This is how we write our reason for co-interior angles. All we have to do is to solve for x. And to solve for x, we're going to take this 110 degrees over the equal sign, and we're going to reverse that operation. The current operation is addition, but when we take it over, it will become subtraction. X equals to 180 degrees minus 110 degrees. Therefore, the value of x is 70 degrees. And that's it. We'll solve for x. Now let's move on to the second example. This may look contrary or different to the diagram which I gave earlier, because we said we're dealing with the letter U in the word fun. However, keep in mind that the letter U can be given to you in different orientations, just like the letter F that we discussed earlier. So, for instance, you can have a scenario like this. In this scenario, those two angles are co-interior, just because we have parallel lines. So the letter U can be tipped over to resemble the letter C, or it can be upside down like this. And those two angles are co-interior, basically looking like the letter N. And then these two are also co-interior angles. So just be on the lookout for the letter U. However, different orientations. So there we go. In this diagram, we also have co-interior angles. And as we have already discussed, these two angles, once we add them, we should get an answer of 180 degrees. I'm going to write that mathematically and say, all I have done is to translate this theorem. Co-interior angles are supplementary, meaning that they add up to 180 degrees. The first angle, which I wrote, is 3x plus 20 from here. Now that angle is represented here. Then the second angle is 2x plus 40, which happens to be that angle. All we have to do is to solve this mathematical equation. And we're going to start by grouping like terms, the 3x and the 2x. We can add those two to get 5x. And then the 20 and the 40, when we take them over the equal sign, they become subtractions, which then gives us 120 degrees. Now all we have to do is to reverse the operation between 5 and x. That operation is multiplication, and the reverse of multiplication is division. So x is equal to 120 degrees divided by 5, which in turn gives us 24 degrees. Let's go back to our statement. Our statement needs to be supported with the reason. And our reason is the theorem, co-interior angles. This time around, our parallel lines are WX parallel to YZ. There we go. So this is how we deal with co-interior angles. Moving on to the third and final theorem. Alternate angles can be represented by capital letter N. Here is a typical example of alternate angles. These two angles here are alternate angles, and they are equal to each other according to the theorem. Let's name this angle A and this one angle B. Angle A equals to angle B. This is our statement, and the reason, alt, that's the shorthand form for alternate angles. Then we state our parallel lines, AB parallel to CD. If we tip over the letter N, we'll come up with the letter Z. This is another scenario where alternate angles can be seen. These two angles are alternate angles, and they are equal to each other. They're not the only alternate angles on the diagram. Right? These are also alternate angles. They're also equal to each other, as long as we have parallel lines. In both examples, we want to calculate the value of x. And if you look at the first example, the positions of the two angles that are given are similar to the diagram that we discussed earlier, that of alternate angles. And I'm going to highlight to show you the letter N or the letter Z. We can therefore use the theorem to say that the angle x is equal to 70 degrees, and the reason, alternate angles AB parallel CD. That's it. There's nothing more we can do here. We have determined the value of x. Moving on to the second example. Once again, that is the letter Z for alternate angles, meaning those two angles that we see are in fact equal to each other. We can say 6x is equal to 150 degrees. That's our statement, and our reason to support it, alt angles DE parallel FG. Unlike the first example, we need to go one step further to actually isolate x. And to do that, we have to get rid of that 6. The operation between the 6 and the x is multiplication. So when we take the 6 over the equal sign, it will change into a division. The reverse operation for multiplication is division. Therefore, x is equal to 25 degrees. Right? We have basically solved for x, or calculated the values of x using the theorem which says alternate angles are equal. If you haven't seen our first video, part 1, where we discussed in detail point theorems, I advise you to go and check it out before you look at the next video, where we're going to be discussing different types of questions and applying these theorems. Until next time, goodbye.